Welcome back. Today, we're going to talk about the power rule, the quotient rule, and the product rule. Mostly product and quotient today, but the power rule will come up briefly as well. We're going to be doing 5 multiple choice and then 3 long answer as well. So let's dive in. All right, so here we're asked if f of x is equal to x squared plus 1 times 3x minus 2, what is the derivative? So in general, the derivative of a product, like let's say we have our original function, which is f times g, where f and g are functions like f of x, g of x, then the derivative, the rule for derivative is it's going to be derivative of the first times the second minus first times derivative of the second. Or sorry, that's a plus there. Minus is for the quotient rule, which we'll get to in another example. Okay, so now let's define our f and our g. So this one here is going to be our f, and this one here is going to be our g. Keep in mind, this f is a separate f from this one. This is just how they're labeling the beginning function. So this here is referring to just this part. Okay, so therefore, what is f? F is equal to x squared plus 1 as we're defining it. G is equal to 3x minus 2 as we're defining it. And then what would the derivative of f be? Well, derivative of x squared would be 2x based on our power rule. And then recall that the derivative of 1, or any constant for that matter, is just 0. So this one just kind of disappears. Then for the derivative of g, we are going to get 3. And then the minus 2, once again, it's a constant, it disappears. So now I'll plug in those values into my derivative of the overall equation, y. So that's going to be 2x times 3x minus 2 plus 2x, or x squared plus 1, times 3. So therefore we have, that's an exact match to b, and so b would be our answer here. All right, let's do the next one. All right, so our next one asks, what's the derivative of g of x? So in this case here, we have a numerator and a denominator, so we should use quotient rule because they're asking for the derivative of a quotient. So what is the derivative of a quotient? So let's say we have, once again, f over g in this case. The derivative of that would be derivative of the top times the bottom minus derivative of the bottom times the top, all over the bottom squared. Okay, so in this case, I'm going to define f. Notice that's our numerator, so that's going to be x in this case. And then g, as we're defining it here, is going to be the denominator of the overall function. And then what are the derivatives? So derivative of f is 1, derivative of g is 2x, right? Just using our power rule there. And then we're going to plug in those values. So y, derivative for y, our overall function, is going to be 1 times x squared plus 4, and then minus x times 2x over x squared plus 4 squared, right? The entire bottom squared. And then I'll simplify that a little bit. I'll get x squared plus 4 minus 2x squared, which is going to be negative x squared plus 4 over x squared plus 4 squared, like that. And that's an exact match to D. And so D is the answer for that one. Here's another one. For h of x is equal to 3x squared, 2x cubed, minus 5x times x squared plus x, the correct application of the product rule is which of these? Okay, so for product rule, recall that it's derivative of the first times the second plus derivative of the second times the first, right? So I'm going to write that down, that if h is equal to f times g, then the derivative of that would be f prime g plus fg prime. Okay, so in this case, I'll define f here and g here. So f is equal to 2x cubed minus 5x. That makes its derivative 6x squared minus 5 if we use the power rule. Then for g, we have x squared plus x. And then for g prime, we have 2x plus 1 by using our power rule. Okay, now I'll plug in those values. So we're going to end up with 6x squared minus 5 times g, which is x squared plus x, and then plus f, which is 2x cubed minus 5x times g prime, which is 2x plus 1. Okay, so let's figure out which of these is correct. So looks like this last one, looks like D is an exact match to what I just wrote when we wrote it out there. And so D is the answer to this one. The next one asks, which one requires quotient rule for differentiation? So the first one is certainly a quotient, and so we could use quotient rule for this one, but I wouldn't say quotient rule is required because I could also rewrite this as 3 to the power 3 times x to the power negative 2, and if I do that, I'd be able to use the power rule to do it, and so therefore quotient rule isn't required. For B, however, it looks like quotient rule is required here because there isn't a way I can just rewrite this with only a numerator. And so therefore I would say B is definitely an answer. C is not an answer because we could use either, we don't have to use quotient rule for C. We could either use product rule, or we could even just multiply these two together with FOIL, simplify, and then use power rule. So either power rule or product rule would work for C. And then both A and B isn't correct because we already stated that A isn't correct since the quotient rule is not required for A, as we could just use the power rule just by rearranging the way A looks a little bit. Just by reformatting A, we can just use power rule instead. All right, and here's one last multiple choice before we get into the free response. If y is equal to u over v, where u and v are functions of x, then dy over dx equals which? So essentially they're saying, what is the derivative equal to in this case when we have a quotient? So all they're really after here is the correct quotient rule formula. I guess the only difference is that they would like this quotient rule formula to be in this formatting, right, rather than the other formatting. So that's the only difference there. The answer would be A though, and let's talk about why. Right? Recall that the original quotient rule formula is derivative of the top times the bottom minus derivative of the bottom times the top over the bottom squared. That already eliminates this one because this one isn't bottom squared. The other ones do have at least b squared on the bottom, so that's good. And then notice that this right here, this means v, right? This is the bottom, and then times du over dx, which du dx is a way of writing derivative of the top, derivative of u, and then minus u, which is the top, times dv over dx, which is derivative of the top, right? Or sorry, derivative of the bottom, rather, right? So here we have top times derivative of the bottom right there. And so therefore that one is the correct one. This one, they switched it around. They did derivative of the bottom minus derivative of the top and then times the correct things. And then here they didn't do the correct derivatives exactly. So A is the correct answer because A gives the correct formula there. All right, let's get into the free response questions. This one asks us to find the derivative using the product rule and show all steps. Now, if we weren't specifically asked to use the product rule, I actually would be advocating for just expanding this and then just using the power rule rather than product rule. But because they asked for product rule specifically, I'll be going through how to do it with the product rule. Okay, so for product rule, let's say we have, let's say this is f and this is g. We know that the derivative, that if y is equal to f times g, then the derivative is equal to y prime g plus fg prime. Okay, so in that case, let's find out what those are. We already know that f is equal to x to the power 4 minus 3x. If I take the derivative of that using power rule, I get 4x cubed minus 3. Then we have g, which we said was 2x squared plus 5x minus 1. And then the derivative of that would be equal to 4x plus 5. All right, so then we're going to do 4x cubed minus 3 times 2x squared plus 5x minus 1 plus x to the power 4 minus 3x times 4x plus 5. Okay, and so there we go. There is our derivative right there. All right, the next one says to differentiate g of x using the quotient rule and to simplify the answer completely. Okay, so let's do that. In this case, recall that if we have y is equal to f over g, that means the derivative would equal to f prime g minus fg prime all over g squared. In this case, f is going to be our numerator and g is our denominator. And then this g of x here, this is actually just like y, right, in this case. Okay, so f is equal to 2x cubed minus 5, which makes f prime, right, the derivative of f equal to 6x squared, and then actually just 6x squared because the constant there, the negative 5, just goes away. And then we have g is equal to x squared plus 1. And so the derivative of g is going to be 2x, and that 1 just goes away once again. So then if we plug that in here, we get 6x squared times x squared plus 1 minus 2x cubed minus 5 times 2x, right? So this is just me plugging in all this stuff into here. And then over g squared. So over x squared plus 1 squared. Now, in this case, they also asked us to simplify completely, so I will be doing that. That said, if you don't want to see this part, feel free to skip ahead. That's totally fine, but I will be doing it just because that's what the question wanted. So I'm going to simplify by using our rainbow rule, or also known as distributive property, probably. And let's go through that. So we're going to get 6x to the power 4 plus 6x squared. And then over here for this part, we'll do the same thing. We'll do 4x minus 4x to the power 4 plus 10x. And that's all over x squared plus 1 squared. And then I'm going to simplify the numerator. So 6x squared minus 4x squared 6x to the power 4 minus 4x to the power 4 would be 2x to the power 4. And then we have 6x squared and then plus 10x. And then in the denominator, we have x to the power 4 plus 2x squared plus 1. And there we go. There is our fully simplified form. And there we go. All right, so here's our last question for today. It says a company's revenue is given by R of x is equal to x times P of x, where x is the unit sold and P of x is equal to 100 over x plus 5 is the price formula. Find the marginal revenue using both the product rule and quotient rule, showing you get equivalent results. All right, so first I'm going to write down the revenue function with the values plugged in. So R of x is x times P of x, which is going to be x times 100 over x plus 5, like that. And so I want to talk about, okay, how could we use both product rule and quotient rule for something like this? Okay, well, when it comes to quotient rule, what the form I'm going to use is R of x is equal to 100x over x plus 5. I could use quotient rule that way. And then for product rule, I'm going to say, well, the thing is, this is the same as 100x times x plus 5 to the power of negative 1, right? And so once again, I rewrote this in order to make it into a product rather than a quotient. And we're supposed to show that when we take the derivative, when we find that marginal revenue, by taking the derivative of the revenue function, that we will get the same results no matter what rule that we use. Okay, well, as long as we use an actual valid rule like product and quotient rule both are. Okay, so let's do that. Let's start with product rule. So product rule, recall that it's derivative of the first, which is 100, times the second, which is x plus 5 in the denominator, and then plus derivative of the second, which what's derivative of the second? It's going to be negative 1 times x plus 5 to the power negative 2 times the first, 100x. And so that's going to be equal to 100 over x plus 5 minus 100x over x plus 5 squared. Now, something I notice is that when we do it with the quotient rule, we're going to end up with just one fraction, right? And so I'm actually going to switch this into that format now because well, that's what we'll end up with eventually anyway. So I'm going to multiply the numerator and denominator for the first one by x times 5, or x plus 5 rather, like that. And then we'll end up with 100 times x plus 5 minus 100x all over x plus 5 squared. And then I'm going to simplify that. So then we'll get 100x plus 500 minus 100x over x plus 5 squared, which is 500 over x plus 5 squared. And that's as simple as we're going to get it. And so that's what we're expecting to get when we do the quotient rule as well. Okay, so now we'll do the quotient rule as well. So going back to this one here, what if I take the derivative with respect to using the quotient rule? Okay, so that's going to be derivative of the top, which is 100, minus our times the bottom, and then minus derivative of the bottom, which is just 1, times the top. And that's going to all be over the bottom squared. And so therefore we get 100x plus 500 minus 100x all over x plus 5 squared, which is 500 over x plus 5 squared. And so notice that product rule and quotient rule, like they're actually equivalent, right? We got the same thing for each. However, because this was a quotient in general, and like we had to go out of our way to write it as a product, it took us a lot longer to get from here to here than it did to get the exact same answer using quotient rule. And so that demonstrates to us a couple things. First off, product rule and quotient rule will both get you the same result if done correctly, but also that sometimes quotient rule, even though it seems like a lot more steps, it can be faster in some cases, and that's why we bother with it. That's why we don't just use only product rule, even though technically product and quotient rule are equivalent in the sense that we could prove one from the other, right? We could certainly derive one from the other. All right, but that's all for this one. If you have any questions, feel free to leave those down in the comment section, and we'll see you for the next one.